Okay, final question. So it's a 10 marker, right? Big question going on here. We can see the starting point actually is polynomials. So let's just work our way through it as we know to do. Show it's a factor. It's paper 2 as well. Okay, we know we should get 0. Okay, restatement, remember, as remainder equals 0. Oops. X plus 1 is a factor. Okay, nice and easy. Then it says, hence solve the equation. Right, so let's sub in what we've got. So what are we left with? We are left with that becomes x plus 1 times your quotient. Remember that bit there. Okay, we're going to factorise it. Again, just do your factorising over at the side, as you know how to do, and then we're going to bring them down. I'm just going to go straight to it because I'm not going to be able to fit it in. Okay, you make them all equal to 0, and then obviously solve for the 3 of them. Okay, so it's about getting it, subbing in your quotient, factorising it, doing it over there, and then bringing them down, and then figuring out where your x values are. Right, then it says the diagram below shows the graph of the equation. It cuts the x-axis at ABC. You can see it's the same curve as what we've just worked with. Write down the coordinates of A, B and C, and then hence calculate the shaded area. Now, if we think about it, these are our 3 answers. Now, if like logically right, that must be -1. The next one, 7 over 2, is bigger than 2, so that must be 2, and that must be 7 over 2. Okay, so A is -1, 0, B is 2, 0, and C is 7 over 2, 0. Okay, so it's about using your answer from part A. Hence calculate the shaded area, right? The shaded area we can see only goes between 2 and -1 of our curve, which is this curve here. So always set up your integral first. Before you do anything now, we can integrate, right? So increase your power, divide by your new power. Increase your power, divide by your new power. Increase your power, divide by your new power. Okay, I'm going to tidy up where I can, so I'm going to make that a 2 on the bottom. That'll become a 3. Oops. Oh my days, why is it doing this to me? That one can't be tidied. Right, sub in our numbers. Again, this was calculator, so we're going to go to it in a wee second. Put your negatives in, really important with your -1 there. Right, we do have a calculator. You can always put this all in one go. You can sometimes get lost. So I would maybe just do them separate, but I would do the whole bracket. So 2 to the power of 4 over 4 minus 3 times 2 cubed plus 3 times 2 squared over 2 plus 14 times 2 is 14 minus, do the same thing. Now, because you've typed it in, you can just go back, obviously, and replace all your 2's by -1. Now, you can do it all in one go, right? But use of brackets would be really important. Like the first one, all in a bracket, as we write down. Second one, all in a bracket. Of course, you can do that. But if you're worried that you would get lost, try when you don't. So we get minus 37 over 4. Bring them together. £23.25. My calculator's saying it could be top heavy as well, which obviously would be fine. Oh, I've just realised I put that over 4, not over 2. Hold on. There's a wee rookie error. Okay, let's just change that. I was just about to say we should always double check, but that is why. Right, let me just check. Okay, it's going to give me minus 9. Let me just check for the first one. Mistakes happen. That's why you should always, I mean, you know there's some previous stuff like in that 5, like things like standard deviation, especially when there's a lot going on. Just double check. 18, there we go. And then that gives you 27. Okay, technically units squared. So when there's a lot going on, yes, you can do it in one go in your calculator. Do it in stages just to make a wee stupid mistake like I did there.